Okay, ladies and gentlemen, let us now talk about trig identities. I'm assuming to say you watched the video for the introduction and also trig, but if you don't have any question, you can mute yourself so that we do fast. The most important thing about trig identities, you have to know few things. For any, you can mute your mic. You are disturbing us already. For any trig identity, for you to know trig identity, everything starts from here. Sine squared x plus cos squared x is equal to 1. It starts from here. This is the parent one. So everything starts from here. Now, we'll start building from here up to the full identities which you have to know. Okay? So everything starts from here. If I shift sign to go to the other side, I can clearly see that where there is cos squared x can be replaced by 1 minus sine squared x. I can shift cos to go to the other side, then I'll have sine squared x is equal to 1 minus cos squared x. The reason why those people who are doing pure, this was the only thing they knew, and few identities. Not so. That's the reason why when you go to university, if you had pures, still it's the same thing with those who had syllabus D. There is no any different. The most important thing again that we have to take note about these identities is to know about sum and different formulas. These are the most important thing that you need to know. Formulas. The first thing that you have to know is about sine. So we say sine A plus B is basically equal to sine. It's a formula. You know, a formula is just something that you need to know, not so. Sine A plus sine plus B in the brackets is sine A, then sine B, okay? I don't want to complicate things, but let me do this. So sine A, I want you to notice few things which are going to be changing as we are moving. Sine open brackets A plus B. So now A can be anything. It can be x. Even B can be x. So sine A is going to be sine A, then cos B. Now here is going to be opposite. Because I've already used the A on sine, then now I'm going to say sine B. Then cos. A I've not used for cos, so it will be cos A. This is the formula that you need to know. So you should pay attention on these signs. This is plus, and I've used plus here. If I go to sine A minus B, this is now minus. It will be the same thing. The only thing is going to change is just minus. So I'll have sine A cos B minus sine B cos A. That's simple, not so? Now, let us go to cos. What if I have cos A plus B? Cos is different. Cos is bit stingy. Cos is like a guy who has got a girlfriend, but he doesn't want to take that girl out. So cos is stingy. So cos, it will be alone. So here I'll have cos A, then again cos B. But because it is plus here, then here it will be minus. The remaining ones is now sine A, sine B. Who can guess the one which I'm supposed to write here, A minus B? Who can guess? It's just the opposite. Who can guess? plus sine A sine B. Like I've said, for cos, you should just be remembering of you have got a boyfriend but he's stingy. So cos doesn't want to go with sine, so it is alone. If it is minus, it will say no, I don't want to go with minus. Okay, so it's like sine is gay. If it is positive, it will go with positive. A man going out with a man, a lady going out with a lady. But cos, because it is positive, say no, 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 I don't want to go with a positive, I'll go with a minus. Interesting, right? Yes. Now let us talk about tan. Let us talk about tan. So tan A plus B, it is basically tan A plus tan B divided by 1 minus tan A times tan B. So this is a formula that you have to know. And I believe the time I sent you a certain video, and I believe you managed to watch, right? These things should not be new to you guys. Huh? I become so lazy, if at all. If at all you are not responding. These things are not new to you, not so? Okay. Who can guess for tan A minus B? Mm-hmm. It's just the opposite, right? A minus B, it will be tan A minus tan B divided by 1 plus tan A times tan B. What we have done, actually, we are done with trig identities, but people get confused if they give you this. I'll start with just a simple thing. Remember, we are talking about sine A plus B. So what will be the difference if I give you sine x plus x? It's basically the same thing, no? Not so? Yes, it's the same thing. So now, if I give you something like sine, open brackets 2x, it's the same as this. They have just added because x plus x is 2x. So wherever I'm going to find sine 2x, it's the same as I have sine x plus x. Then now I can use the sum method. This is going to be equal to sine x cos x plus, again, because this is also x, then it will be sine x cos x. Who is behind here? I've gotten it from just the basics. No one is behind, right? Respond so that we go to the next step. Then this is going to be sine, then 2x. This and this guy, they are just the same thing. Then it is 2 sine x cos x. So this is now identity number 1. The important identities. Identity number 1. Where you are going to find sine 2x, you have to replace it with either, you can replace it with this identity, which is 2 sine x cos x. Do you guys remember back then in physics under projectile motion, when we were talking about that formula for finding the range? Then we were saying Because of 2 sine x cos x, we are going to replace with sine 2x, which was theta in that case. It was 2 sine theta cos theta is going to be replaced with sine 2 theta. It comes from this identity. You understand? This is the same for everything. This is the same for everything. If I go to cos, but before we go anywhere, let's first try to do something there. So if we go to cos x plus x, we know that cos it will be just cos x times cos x. Because of plus there will be minus. Then sine x times sine x. So this is going to be cos 2x will be equal to cos x times cos x is cos squared x minus sine x times sine x is sine squared x. Who is behind here? Who is behind here? Huh? Nobody is behind. We can continue. We don't want to waste time. And then one thing, this is now the main thing I want you to understand from here. This guy is very important thing. Remember the first identity that we talked about? So where there is cos 2x, well, you can replace it with this. But cos 2x has got more than one identity. It has got 3. Okay? Why am I saying it has got 3? There we go. We do know that where there is sine squared, x can be replaced by 1 minus cos squared x. So I'll go ahead and say cos 2x will be equal to cos squared x minus open brackets. Where there is sine squared x, I will replace it with 1 minus cos squared x. I can now open the brackets. Cos 2x will be equal to cos squared x minus 1. Now negative and negative will be plus cos squared x. This and this, they are the same. It will give me 2. So cos 2x will be equal to cos squared x plus cos squared x is 2 cos squared x minus 1. So this is another identity that we should know. So cos 2x can also be replaced by, this is the first identity, and this is now the second identity. It's making sense, not so? Another one, from here, I can replace, I know that cos squared x another identity, because I don't have space here, I can just say, I can put it here. Cos squared x can be replaced by 1 minus cos squared x. So then I can shift this, should come down here, and then I'll have, where there is cos here, I'm going to replace 1 minus this is supposed to be sine. No one noticed. So cos 2x, where there is cos, put 1 minus sine squared x. Then there's also minus here, sine squared x. These two can be added, so it's 1 minus. So it will be equal to 1 minus 2 sine squared x. This is another identity. Who is behind? Where? Mhm. Also x is a theta. It's an angle, so we don't multiply the angle. Yes, you just focus on the trig. Yes, yes. So you should not say sine squared x squared, no, because that is the angle, so we don't multiply the angle. The angle remains the constant. It's okay now, right? Thank you. Now let us go back a bit. We have come up with these identities here, which are, we have said cos 2x can be, so x can be anything. It can be, they can use theta, they can use a, they can even say cos 2a. You get my point, right? Not, no, they didn't tell us about a, they didn't tell us about the theta. It's the same thing. It can either be theta, but they can use anything as long as it's the angle. Then it will remain the same. Nothing is going to change. Does that make sense? It does. So we have come up with the first identity that we have said 2 cos squared x minus 1. Not so. That's what we said. Now, another thing here, I can shift 1, go to the other side. Then it will be 1 plus, because 1 now is going to be positive. It will be 1 plus cos 2x is equal to 2 cos squared x. Allow me to start writing this to go to the left side, then the other one should go to the other side. But nothing is going to change. So I just want to start writing this. Then this will be like this. I have not changed anything. I've just started writing 2 cos x squared. Not so. I hope no one is behind there. Hey, guys. Okay, so now here I can divide everywhere by 2. Even here I can divide it by 2. So 2 and 2 will go, and then I'll have cos squared x will be equal to, do you guys know that if I have got x plus y divided by 2, it's the same as x over 2 plus y over 2? You know that, not so? So this is the same as 1 over 2 plus, okay, plus 1 over 2, then I have cos 2x. When I reach at this point, I'm going to factor half here. So there's a reason why I'm doing this. I'm going somewhere. Cos squared x will be equal to, I'll factor out half. I'll remain with 1 here, plus here I'll remain with cos 2x. So there is also another identity that you need to know, that cos squared x can be also replaced by this. It's also another identity. Okay. Then there is also another one. At this point now, I'm going, because here the angle has got 2, I'm going to focus on the angles only. I'm going to divide here by 2 where there is angle only. Okay, I'm going to divide here by 2, even here by 2. So you're going to realize that this guy and that guy will cancel out. So I think you have heard of half angles. So I can put them in brackets. So what they're actually they're talking about, it comes from here. So this is also another thing that you need to know. It's interesting, eh? it is interesting, very much interesting, very much interesting. Anyone who is behind? No one is behind, but anyone who has got a question? Hmm? Hello? Hello? Uh-huh, now it's good that we are together.
I wanted to say something.
Yes, please say something.
Actually, it's a concern because most of the videos I've watched you present,
Mm-hmm.
you always find a way of saying how you can remember this. When you started now, but as you go, you just keep on saying this is an identity. You keep on doing. From my side, I'm even lost now. I started quite. I was quite confused. Now you keep on saying this one, this one, this one, this one. So basically, my question is there a way of making it easier of us remembering the necessary identities? Because
Okay,
I don't know
so
my colleagues, but for me, I'm lost.
I get you, sir.
Okay.
So my goal here is to show you where these identities are coming from. When we are done, then we are going to write now the identities that we have come out up with. Then I'm going to tell you the most important identities that you have to know or that you have to master. So basically, what I'm doing, I'm just because you're supposed to know where they're coming from, not so. So I'm actually driving them.
Okay.
Yes, yeah, that's what I'm doing. hmm So then there's also another thing. I think you have seen something like this. So don't worry about that. I'm going to give you a sheet where you are supposed to. It's going to help you for the identities, but there are most important identities that I want you to know. Now, because here there is squared, I can square root both sides, and I'll end up having now what? Remember, I said if I have 1 over 2 plus 1 over 2 is the same as 1 over 2. So then this one I can also rewrite it to say cos squared x over 2. This is the same as 1 plus cos x. Then I divide it by 2. I have now simplified this part. To get rid of the square where there is cos here, I can square root both sides. Perhaps you have seen this and you didn't know where they are coming from. Then here they put plus or minus. So the 2 here and the square root will go, and I'll have this x over 2 being equal to plus or minus the square root of 1 plus cos x divided by 2. So they say this is also another identity, but I have been teaching math for the past 6 years, but I've never seen any identity where you have to replace with this. So these are what we call unnecessary things. You get my point, eh? Yes, so these are something that you are not supposed even to waste time to master. They can't come. But
they don't really come after struggling to understand them.
but in a case where just
Actually, I'm
no, just a minute. In a case where they give you this and then maybe they tell you to say they but anyway, I think you can use it in a case where they say find this. So when they tell you to find this, you can replace it by this and then find the answer. I think it's important. Let's take everything to be important. Okay? Another one, it is also coming from the same one we derived. Remember? So now the basic thing is start from here. So everything starts from there. So I gave you another identity to say it was 1 minus sine squared x. You remember? It was 2 here. Is that okay? So let us go ahead and shift this to go to the left side and shift this to go to the other side. So we are going to have 2 sine squared x is equal to 1 minus cos 2x. Have you seen where this is going as well? Oh, you already grown. I want to make the same things I was doing. Have you seen where this is taking us now? It's how people are asking in the group every day, how much per course? Every day, how much per course? Okay, so I'll divide here by 2, even here by 2. So then 2 and 2 will go. Sine squared x is equal to 1 minus cos 2x over 2. So then what I can do, I can say sine, another identity, I'll just get it from here. Let me not waste time. I'll just get it from here. Another identity where there is this sine squared x, you can replace it with that. Okay, there are some cases where you can replace, we do know that quite okay, sine squared x can be replaced by 1 minus cos squared x. But in a case where that doesn't work out, then you can replace it with this one. Does that make sense? Yes, it does. But the most important thing that I wanted you to know is this. Do you know that if you know this and you know this, everything is going to be simple for you? What if I give you sine 3x? This is the same as what? Using the sum and different formulas. What is sine 3x? Guys, muzancho samu.
On my part, I don't know.
On your part, you don't know. But
3 times 8 cos x.
it's going to be what? No. Just, this is the same as, in simple terms, sine 3x is the same as what?
2x plus x.
Exactly. So it's the same as 2x plus x. So this is what I want you now to start thinking. Forget about it. That's why I told you to say, sometimes these identities, for me, it's very difficult for me to master them. But I'm able to drive it. You get what I mean, right? So what I mean is, I know that sine 3x is the same as sine 2x plus x. Who is behind why sine 3x is sine 2x plus x? What we are doing here is not only identity. Even solving equations, it starts from here. Because if you don't know this part, then you can't prove identity. You can't solve those two things that given that sine x is equal to what, then solve for maybe 2 sine 2x. You can't solve an equation. So this identity, driving the reason why I teach this part is going to help us to answer 3 types of questions. Who doesn't know that sine 3x is sine 2x plus x? From what we have done, we can prove any identity and we can answer any question involving identity and we can solve any equation. There we go. If you think I'm joking, let us solve this question. I have made this thing to be very much simple. I want you just to know that sine 2x can be replaced by 2 sine x cos x. I also want you to know that cos 2x can either be replaced by cos squared x minus sine squared x, or it can be replaced by 2 cos squared x minus 1, or it can be replaced by 1 minus 2 sine squared x. If you know these identities, because no one can tell me to say you don't know that sine squared x plus sine cos squared x is equal to 1. That one you know it, right? So everything starts from here. These are the basics. Because if you know sine 2x, then you can derive the formula for sine 3x. You can derive the formula for sine 4x. Who can tell me what this is going to be? This is the same as what? Sine 4x. And Sankoni, time is not with us. Who can tell me what sine 4x is?
I think it's sine 2x plus 2x.
Exactly. Yes. So who doesn't know that sine 4x is equal to, this is a bit, try to ask, guys, please. Okay. The one who was asking about which identities are we supposed to know? Sir. So these are the identities that I want you to know. These are the major ones. Like the major ones. Everything starts from here.
The one we are seeing on the board.
The ones you are seeing on the board. This guy, this one, this one, this one. And those ones, sine. These ones, you already know them. Sine squared x plus cos squared x is equal to 1. You shift the other one to go to the other side. Those ones, not so.
Yes, sir.
Yes. Now, another thing that you guys are supposed to know is this. This question I gave you was simple and straightforward. It was like this. Given that cos x is equal to 3 over 4. Before you even finish the question, what should be in your mind right now is that cos x is equal to 3 over 4. It is positive. Where do we expect this cos guy to be? And it is positive. So where do we expect it to be?
In the fourth quadrant.
In the fourth quadrant. For the fact that it is positive, cos is positive in the fourth quadrant and in the first quadrant. But why can't I assume that this is in the first quadrant? Okay. Cos is also positive in the first quadrant. Why can't I say this is in the first quadrant? Why? Why have we gone with the fourth quadrant?
Because of the range is different.
Exactly. Can you repeat it? Some people are not. They are here, but I think they have not gotten your answer.
I said because of the range is given.
So because of the range that we've been given that it has to start from 180 all the way to 360. They are not saying it has to start from 0 all the way to 360. No. So that's why now we have concluded that this is in the fourth quadrant. Now you have to draw this line. Such kind of questions are very simple. So draw a line, then it will be like this. In the fourth quadrant. So this is my x, the angle. So cos, using SOHCAHTOA, so adjacent is 3, hypotenuse is 4. To find this guy, let's assume that this is A, this is B, and this is C. So to find B, we know that this formula is given by c squared is equal to a squared plus b squared. We know this one, from grade 12. Yes, we know it.
Yes, sir.
Then I want to find b, shift b to the other side to be b squared is equal to c squared minus a squared. get the square root, so it will be c squared. What is my c? My c is 4 squared minus a is 3 squared. So then it will be the square root of 16 minus 9, which is 7. So this part is the square root of 7. You have cos, so you need to find sine as well. So then I'll say sine x will be equal to sine is opposite, which is root 7 divided by the hypotenuse, which is 4. But this is in the fourth quadrant. In the fourth quadrant, sine is negative, so include negative here. If you just forget negative, then you are gone. You are gone. You are gone. UAG. You are gone. Let us go ahead and find tan. Tan x, tan, it is opposite over adjacent. Opposite is root 7. Adjacent is 3. Tan in the fourth quadrant is negative. Include it like that. When you do that, now you can go ahead and solve the questions. Let's start with the first one. For the fact that it is me myself, I know that sine 2x is equal to 2 sine x cos x. I know. But I'm not going to show you direct like that. I'm going to show it like this. Sine x is the same as sine 2x is the same as sine x plus x. Then go there and say it is sine x times sine x plus cos x times cos x. Then you go back, sine x and x inside there, you end up having 2x. Then again, this is going to give you no. So you guys are just watching me. I'm supposed to put cos here. Here I'm supposed to put sine. Here I'm supposed to put sine. So then it will give me 2 sine x cos x. When I do that, now I just go back and plug in the values. What is sine x? Sine x is the root of 7 divided by 4. Then cos x is 3 over 4. Now 2 and this 4 can go. I can remain with 2 here. So I'll have negative root 7 times 3 is 3. Negative 3 root 7 divided by 2 times 4 is 8. Then this is my answer. Have you seen how simple these things are? Come on, guys. Have you seen how these things are simple?
We have seen, so we have seen.
You have seen, huh? They are becoming interesting now. Now, someone to go ahead and tell me this. Now, I can't plug in direct the formula for sine 4x because I have to do something. Now, we have said, a certain girl said sine 4x is the same as 2x and plus 2x, not so? Then I know that this is going to be sine 2x cos 2x plus sine 2x cos 2x. But you guys already know that these things are the same, so it will be 2 sine 2x cos 2x. Now instead of me, I can't solve this the way it is direct. I have to replace with another identity. Remember the identity for sine 2x. So what is the identity for sine 2x? Come on, guys, you can do this. Come on, guys, you can do this. What is the identity for sine 2x? We are from doing it. 2 sine x cos x. Now, which identity should I replace with cos 2x? Any. I can choose any among those two I gave you. In fact, among those three I gave you, you can choose any. Which one do you want to go with? What is the first one? Cos cos 2x minus cos 2 at what? Cos 2x minus sine 2. So you have already forgotten, my friend. We have never talked about this. Yeah, so that's what she wants. It's supposed to be squared, right? Okay, so we can use that one, or we can use the simple one, because that one we need to start now squaring. You know what I mean, right? But it's the same thing, but we need to start squaring. But I can just choose a simple one to say 2 cos x minus 1, like this. But still, that is also correct. So then 2, what is sine x? Sine x is negative root 7 divided by 4. Cos is 3 over 4. Then here again 2. Then cos is what? Cos is 3 over 4 minus 1. Now you can simplify this and find the answer. Not so? Which other question do you want us to solve from here? Choose. Which one do you think it can be difficult for you? Because other questions you're supposed to solve. Then I'll be reaching at the certain step, then I'll say, okay, you can find the final answer. Which one do you want us to solve? We go for sec? Should we go for sec? Don't you think that if we do sec... Okay, we go for tan. But what if we start with cot? Anyway, it's fine. So one thing I want you to understand is that tan is sine. Tan x is equal to sine x over cos x. Who doesn't understand this? Hello. So if you know about that, let me know so that we continue. You know about that. Then what should come in your mind is that if I have tan 4 x is basically the same as sine 4x divided by cos 4x. So there is no difference. Now I have to simplify sine 4x, which is the one we were simplifying here, if you can remember, and also simplify cos 4x. So cos 4x, you have to do it like this. So it will be 2x plus 2x. It will go back and say we have cos 2x times cos 2x minus sine 2x times sine 2x. Not so. Then this guy and this guy will give me cos squared 2x minus sine squared 2x. Not so. Guys. Now, how can we dismantle cos squared 2x? Tien nazo. How can we dismantle cos squared 2x? Tien. This is where now we are supposed to think. So again, there is a formula that we have to know about that one. So let me just put it here so that you should also know. So this is the most important thing of solving questions, so that you should be able to know. So wherever you see there is also another identity, although we have not managed to derive it, I didn't want us to waste time, because 2x, it is given by 1 plus cos 4x, then you divide it by 2. But if you look at this, there is no difference with the one that I gave you, because if we divide here by 2, we will still end up having 2x here, and here is going to be x. Do you remember those formulas we had? So what I'm trying to tell you guys is this. Let me just go to the next page a bit. Who remembers this? I gave you this. Then we had 1 plus cos 2x divided by 2. You remember what I said here, right? Guys, mzanchosa mukairimu. You remember what I said there, not so? So now, what is happening here is that because here there is 2, once there is 2 here, 2x, then I can replace now where there is angle. I'll just change where there is angle. I'll do times 2. So it's the same thing, but here it will be 4x. 2 times 2 is going to be 4x, like this. What if I get to have this? What will happen? What will happen? From what we have done here, what will happen? Guys, what will happen? What are we going to have if I have got cos squared 3x? What are we going to have? So, but have you understood here what I've said? Because if you are quiet here, meaning you have not gotten anything there. Or we end here.
1 plus cos 6x.
Yes, exactly. So that's the logic there. You are just playing with the angles, that's all. So when I tell you to say ask, if you're not asking, then I give you questions, you fail to answer. I'll not come back and explain about the same things, because you're not asking questions. Okay, you're not asking questions. So, okay. The only difference that I want you to understand here is, whenever we're talking about cos, these things are the same, cos and sine. The only difference is, whenever we're talking about sine, there will be minus here. Everything is the same. So if I have got sine squared x, is going to be 1 minus cos 2x divided by 2. So now what if I have got sine squared then 2x? What are we going to have here? Mucho sana mo guys.
4x over 2.
Okay, that's what we're going to have. So this is what we're going to do here. I have removed everything. So this is what we're supposed to do. So now we are talking about tan. We're talking about tan 4x. So now this is going to be sine 4x. You know sine 4x already, we have talked about it. Then cos 4x. But because we have said you end up having this guy is going to give you cos squared, then you're going to have 2x minus sine squared 4x or 2x. So where there is this guy, you are going to replace it with this one. And where there is this one, you are going to replace with the one which is going to be 1 minus cos 4x. Just like that. What is the problem now? If I may ask. No pressure. But the most important thing I wanted us to, because those ones we are just solving, but I wanted us to look at one identity, which is the most interesting identity, which is part A. Have you seen how part A is? But now how can we prove that one? Using the same knowledge we have just gotten here. So I'm going to copy this question. 4 cos to the power 3x minus this is equal to that. Can you help me to remember the question? I've even forgotten. I think it is 4 cos to the power 3x minus 3 cos x is equal to cos 3x. Let me go back. It's the same one, right? Guys, you're not active. So there's no any motivation. You're not motivating.
Sorry,
Venangu bari ku market. Okay. Mute your mics. So we don't have enough time. So if you keep on unmuting yourself, we are not going to do a lot of things. How do we know that I'm supposed to prove that this guy is equal to this guy? We have got two parts, the left hand side and the right hand side. Look for something that is easier. What do I mean? It will be very much easier for me to dismantle this, but I don't know how it's going to come. But as we are going to be solving, then we'll be able to know. But because we have this, let's replace this with this. You get my point, right? That's how simple identities are. Now here I can't use, yes, quite okay, I can use left hand side to prove that is equal to the right hand side, but look for something that is going to be easy for you, because definitely I know cos 3x. So then you have to write here to say I have chosen what? Left hand side. Write here left hand side, underline, get the left hand side like the way it is. Say that this is the same as cos 2x plus x. Not so. Again, tell them that this, if I dismantle it, is going to be cos 2x cos x minus sin 2x sin x. Who is behind here? I want to prove that this guy is equal to this, but I can clearly see that sign is not appearing. I need to find a way on how I'm going to eliminate this sign. Okay? Now, let us go ahead and choose the identity that is only involving cos to replace it with cos 2x. That's how simple these things are. I don't have anything that has got sign this side, so I can't use for sign. So therefore, 2 cos 2x can be replaced by, I can replace that one with 2 cos what? Cos squared x minus 1. That's what we said. Now, because there is another cos here, I'll put it here just the way it is. Cos x minus sin x, sin 2x. Sin 2x has got only one identity, which is what? Which is 2 sin x cos x. Then I also have sin x outside. Now let us now expand this. If I multiply cos with everything inside, I'm going to have 2 cos to the power 3 minus cos x. At least cos to the power 3 has appeared. At least cos to the power 3 has appeared, and that's what I want. Let's go ahead. If I multiply sine with everything inside, I'll end up having 2 sine to the power 2, then I'll just have cos x, like that. I have multiplied sine with what I have inside the brackets. Remember, we don't want sine to appear. So where there is sine squared, I can replace it with 1 minus cos. So I'll go ahead and say 2 cos to the power 3 minus cos x minus 2 open brackets 1 minus cos squared x. Then again outside the brackets there is cos x. Without wasting much of our time, I'll continue and say 2 cos to the power 3 minus, so there is that I'm supposed to put x here, then cos x minus. Now let us open the brackets. Or before we open the brackets, we can first multiply it by cos with the things which are in the brackets. But don't you think that this is the same as just 2 cos open brackets 1 minus cos squared x? It's the same thing. It's the same thing. When I do that, this is why I was telling you to say identities are something that is very simple. When I do that, the next thing that I have to do is I now multiply this with what I have inside. Now I can clearly see that I no longer have sine because I just want cos. So I'll rewrite this. 2 cos to the power 3x minus cos x minus, if I multiply this with 1, I'll end up having just 2 cos what? 2 cos x, like that. Then minus, it will be 2, now it will be plus. Because of this negative and this negative, now cos times cos, it will be plus 2 cos to the power 3x. Now these are right terms, they can be added, even this can be added. So 2 plus 2 is 4 to the power 3x, and this is what I want. These 2 can be minus 3 cos x, and this is what I have. You reach at this point, you tell them to say left hand side is equal to the right hand side. Hence, proved. What is complicated here? Tell me. If you have seen how I have proved this identity, I have only used the concept of those 4 identities which we have just derived. The sir who was asking the question, I don't know if he's still in to say something.
I'm still in, sir. I'm still in.
How is it so far?
Yeah, so far we're trying to catch up. I think with practice we will catch up. I think it's looking like this maybe because it's the first time.
Okay. Okay, so if at all I give you other questions, now what, since we have covered this, if I give you some questions based on what we have done and trying to prove some identities, can you try to do so?